everyone, and welcome to Zero Day Dispatch's monthly dialogue series. I'm Priya, the founder of Zero Day Dispatch, and I'm joined today by Rohana, our Cyber Policy Research Associate, and Irene Courtney, our Community Outreach Coordinator. This strategic dialogue explores community-owned, cooperative, and/or state-supported alternatives to industry-led 5G infrastructure. As 5G expands globally, many low and middle-income countries remain reliant on foreign telecom giants and cloud providers, raising urgent questions around the ownership of digital infrastructure, control over connectivity, and concentration of big tech dominance. This discussion will cover regulatory models like citizens' broadband radio service, local access licensing, while offering practical open source solutions for building local 5G networks and more. Before we introduce our speakers, Rohana will outline some basic housekeeping rules for the session. Hi, Rohana.
Welcome, everyone, and hi, Priya. Before we dive in, let me quickly run through some Zoom tips to help us have a great session together. This will be a 1-hour discussion. There will be 10 to 12 minutes allotted for our guest speakers. The last 15 minutes are allocated to the audience for their questions. Please be aware that this session is being recorded. By participating, you consent to being recorded. All attendees will be muted throughout the presentation. Only the speaker and the host will have their video on. Attendees can keep their video off or on. Please use the chat box to submit questions. We will address them during the Q&A session at the end. We recommend using Speaker View for the best experience. This recording will be submitted to various social media outlets. It will be free of charge and for educational purposes only.
Thank you, Rohana. And I'm delighted to introduce our first speaker, Steve Song. Steve is the Senior Director of Infrastructure Mapping and Development at the Internet Society and a longtime champion of open, equitable Internet infrastructure. Since 2009, he's been maintaining public maps of undersea and terrestrial fiber networks across Africa, making critical connectivity data more accessible. Welcome, Steve.
Thank you for the opportunity to be here and to participate in this session today. A conversation about 5G and community networks has to start, I think, with, well, what is 5G? 5G is a technology that comes in a long line of technologies for mobile communication. You know, the first mobile phones were 1G and they supported voice technology. Then came 2G mobile phones, which supported text messaging and voicemail. 3G, which was the first generation to support data, which came along with the iPhone, which really transformed mobile phones from a voice technology into an internet technology. This then led to 4G, or what is also known as LTE, which finally brought real broadband to mobile devices, and I think sparked a wave of uptake of internet in places where it had never been before. And 5G was proposed to be as big a revolution as that, enabling everything from self-driving cars to robotic surgery. And I think that hype bubble has long since been burst, and it is an incremental improvement on LTE and an improved technology, but it is basically more of the same in terms of more bandwidth, lower latencies, etc. But in order to operate any of these generations of technology, you need access to radio spectrum, right? You need access to frequencies in order to broadcast on and communicate on those frequencies. And the way those frequencies are given out have typically been through national licenses, right? So a national license is assigned to an operator who gets, frequency X, and that license grants them the right to exclusivity throughout the entire country for those frequencies. And because the demand for those frequencies exceeds the availability of them, they had to come up with a mechanism for making them available, and that mechanism was auctions. They auctioned it, the spectrum, and now these licenses to these frequencies for mobile goes for millions and sometimes billions of dollars. The goal in doing that was to ensure that those who got the licenses would make the best use of them. And the theory goes that by paying that much money, they would ensure that somebody would build a network in order to recoup their investment in it. And that has worked to some degree. The alternative to these spectrum licenses is another successful technology called unlicensed spectrum. And unlicensed spectrum operates in a different way. And I'll illustrate this with an example. So when I say unlicensed, I mean, you can think Wi-Fi and Bluetooth and technologies like that. Imagine you are in a conference room, right? And that conference room is full of, round tables that you typically find and is filled with people. And you want to communicate with everyone in that room. Well, for a mobile operator who has a license to operate in that space, that license allows them to effectively shout or say have a microphone and speakers. So they're on the stage, and when they speak, everybody hears what they're saying. So for a mobile operator, you can reach everybody in the room because you have complete control of who's speaking in the room. Whereas if you didn't have access to that microphone and speakers and you wanted to reach everyone in the room, you would have to go and sit at each individual table in the room and communicate with the people at those tables. And that's kind of like how unlicensed or Wi-Fi spectrum works, in that everyone gets to use the same spectrum, but they have to speak politely and quietly. And so if you want to build infrastructure to reach everyone in the room as a Wi-Fi operator, then you have to build a lot of, you have to put a person or, an access point at every single table. And for a small operator, that can become challenging if you want to scale. For 5G, 4G, 3G, you only need that one tower to reach everyone in the room. And that's the big difference between license exempt or unlicensed technologies like Wi-Fi and 5G technologies. Now, why is this important? It's important because large operators are not delivering services to everyone in the country. And small operators, both commercial and non-commercial, are playing a critical role in delivering services into unserved areas. And it's critical to create the enabling environment for those operators to thrive. Now, mostly those operators are using Wi-Fi because it's all they can gain access to. But it has this limitation of having to build complex and very, very detailed infrastructure in order to serve a community. So now, with regulation like CBRS, the Citizens Broadband Radio Service, which breaks up 5G from a national license into local licensing, suddenly ISPs and community networks can gain access to the frequencies that allows them to speak to the whole conference room instead of having to build these kind of smaller, much smaller infrastructures. It gives them a lot more power. And so what we're talking about today then is how can community networks and small operators build 5G infrastructure to deliver affordable access. Now, I think what we're going to hear from the next two speakers are the practicalities of how you build those networks. But key also is to have the enabling regulatory environment that unlocks access to that spectrum for small operators. CBRS is pioneering regulation globally. Nobody has done this kind of use it or share it mechanism anywhere else in the world exactly the way the US has. It has unlocked a 4G, 5G spectrum to a host of new operators. It's great. It's under threat. Right now, there's pushback from the current government to actually auction all of that spectrum as a kind of cash grab. And so from an advocacy point of view, it's critical to have voices at the regulator to say, look, no, we need this kind of granular access, low cost access to 5G spectrum in order to bridge the digital divide. Now, I can also talk about examples of how this is being done elsewhere around the world, but I think I'll pause there and maybe bring that in later on in the conversation.
Thank you so much, Steve, for this wonderful conversation. Now, moving on to our second speaker. Our second speaker here is Mo Saman, a solutions architect, private 5G specialist, and a cloud telecom innovator at Phoenix TPI. With 20 plus years of global experience from the US to Latin America, the Middle East, and Europe, Mo has led groundbreaking work on private 5G, open source cellular, edge computing, and cloud native architectures. Welcome, Mo.
All right, folks, can you hear me?
Yeah, we can hear you.
Okay, I'm trying to share a screen. I'm having challenge sharing a screen. Please give me a moment.
No worries.
Okay. All right, here we go. Are we seeing this?
Not yet.
Not yet, almost. There we go.
Yes.
Okay, great. Well, thank you very much. I appreciate it. Thank you, Steve, for the great explanation. Just adding on top of what you had mentioned, I'd like to take the small amount of time that we have and explore how we can build an affordable private 5G solution based on open source software and commodity hardware. This is a vast topic when we start to, uncover 5G because it's really an intersection of RF, software, networking, cellular. There's a lot there. However, in this presentation, I'll try to scratch the surface and kind of point at solutions that we can use. I've tried these solutions. They work well. I have not scaled them, but they can be scaled. So let me proceed with the next section here. So I'll start with, what if there was a way where you could deploy a private 4G or 5G solution or network deployment at a fraction of the cost with minimal vendor dependence? Excuse me, when you buy software from the vendors, you always end up having a lot of licensing fees, a lot of updates that need to happen. That needlessly takes a lot of time. Excuse me. And that's a challenge for rural ISPs or even enterprises that wish to deploy private cellular in their facilities. A lot of times we're faced with limited budgets, lack of connectivity, geographic barriers, and this is where we can make use of that CBRS spectrum. But why are we going towards cellular as opposed to Wi-Fi? Much like was explained by the last presenter, there are challenges of deploying radios, but also there are certain benefits that 5G brings in addition to Wi-Fi. While there are many, I'll just touch on some of the high-level ones, which is extended coverage. Just the way it's set up, it gives you better coverage than Wi-Fi. It has battle-tested security. The security that's built into cellular networks has been around for, gosh, I want to say 30 years and only improving. It can provide a higher level of users in coverage area than Wi-Fi can. It has, much higher control, and it really is low cost when you consider what you're covering. All of these challenges really point us to try and explore a solution that is cost effective for a rural operator trying to connect via the CBRS band or any band that's available in your local geography based on government definitions. Here in the US, we'll be using CBRS. So the vision in mind is to create an open source solution based on commodity hardware and open source software and turn it into a production grade system. A lot of these open source solutions, I know many people, when they hear the term open source, they're like, oh my God, is it going to work? Is it really production grade? You'd be surprised that the likes of Nokia derive software forks from these open source solutions and increment on them and just make them a product. So yes, they can easily be made production grade. And just as was mentioned about the spectrum, in the US at least, the Citizens Broadband Radio Service gives you 150 megahertz worth of bandwidth. However, there are layers. There are incumbents like the Marine, the government agencies, and then there are those who have purchased priority access licenses for CBRS so they can have, best coverage guaranteed service. But then there's also the general authorized access, which mediated through an FCC mandated server controls frequency allocation such that interference is mitigated and there's a certain level of control that goes on there. Now, what exists in a cellular 5G or 4G network? We have the handsets or the modems. We have a SIM card. We have the spectrum that we must select depending on your locale. We have antennas and we have radios for 4G and 5G. We have the associated cabling. We have a baseband processing unit plus a GPS puck, which is just for timing in order to keep the system synchronized. Then we need a front haul and a back haul, the cellular core, and some routing logic. All of that in a diagram looks like this. In order to build a minimum 5G solution, we'll need to create at least this. This starts from the UE all the way to a destination IP network. So in this diagram, starting from the left, you would have either a standard modem or a standard 5G phone that can handle CBRS. Then you have, whether it's an indoor or an outdoor coverage, you have your mast plus the antenna and the radio. Then a next level, which is the signal processing. That's just a common off-the-shelf server. Just take any 1U x86 server and up to a certain capacity, it will control the radios and do all of the radio work that's required for 5G. Then as a next layer, you have the core stack, which we'll get into just a little bit in next slides. Also within that ISP's domain, there will be the need for routing. And a lot of times people don't go out and spend money on routing gear. There are open source solutions for that as well. Okay. So trying to build this, what would we consider? Let's take this as a small project and try to build such a system. The UE is any 5G capable phone or even a 4G capable phone, really, that can handle CBRS in the US or your frequency in your locale. There's the radio, which we can use an experimental software-defined radio like the one you see below with the printed circuit board. Or you can go for solutions that are under $2,000 a lot of times, smaller solutions, but very cost effective, like the ones I've placed here. Now, the software we'll need for the baseband processing will be from SRS RAN. This is, here's the link. You can look it up. It's quite detailed, but just to explain in short, it's basically the radio software for 4G and 5G networks. It's been tested with several cores, even large vendors use it. Then we have the cellular core. I have presented Open5GS. There are others, but this would connect as a backend to the radio. Then that's the radio, the routing logic. We can use FR routing. So what do we have to do? To connect a UE to a 5G network, we need a device, we need a PC, we need to download the SRS RAN project and have it run on a PC. Then we need to download the 5G core and have it running on a PC. We will need SIM cards and we will need a GPS puck. in addition to the radio. So I've tried to refer to these on this slide, but there's a lot, and I don't think I can get into more details on any of these. But just short to say that the antenna is something we can't readily make. We could build a radio. It will take some time to modify it to your needs, but you can also buy a cost-effective radio and antenna and just use the two software backends to minimize all your costs in terms of licensing. Now, if you were to make such a deployment, just like any other wireless deployment, you have an initial site visit, then you do a coverage simulation, then you do your network design based on that, then you do the core and radio install, which we just talked about, then you build in monitoring and optimization and help desk. A project like this really is at the intersection of cellular, software, and commodity hardware. So it draws from a few practices, but it's possible to tie them all together. The setup that we just described above creates an end-to-end data path, an IP stream, if you will, from the from the UE, the user device, all the way to the transit destination network. You can add voice or video services, again, with more open source solutions. And I just want to say in this journey, Linux and open source are your friends. In the end, you will have something like this. This is readily out of the box in Open5GS. The lower part where you see here is a 4G modem, software defined like we discussed, or a 4G radio or a 5G radio, where modems and UEs can connect to. They both come back to the same core. It's a combined core for 4G and 5G. It has a separate data plane and a control plane. The control plane is to the left top, the user plane or the data plane is to the right. You can basically tap into any of these interfaces and do an IP capture and examine traffic as needed. So a few operational considerations to keep in mind are OSS, operational support systems, and business support systems, things like creating customer account management, invoicing, payment. There's a whole life cycle there that needs to be fulfilled if you wish to, take care of customers in the way an operator should. But then there's also the back-end monitoring. You need to do things like configuring, fault management, service provisioning. These are all defined in TM forum and can be readily found online. And finally, some sample radio vendors that we can draw upon if we don't want to go with a software-defined radio. I just put that list here, and feel free to look through those. And finally, we've tested this out. We've had it working, and it works both for 4G and 5G. So if there are questions, my email's here. Feel free to reach out to me. Thank you.
Thank you, Mo, for your insights. Our final speaker is Esther Jang. She's a PhD postdoctorate in computer science at the University of Washington. She's a director at a local nonprofit called the Local Connectivity Lab and founder of the Seattle Community Network. She has installed community networks in the United States and around the world. Thank you so much for joining us today, Esther.
Also figuring out screen sharing. One moment. Can you see my screen?
Yeah, we can see the screen.
Okay, great. Yeah, so I think this is actually a pretty good follow-on to the last two speakers because we will talk about a lot of the same things. So I run a project called the Seattle Community Network in Seattle, US, and this is an abbreviated version of my thesis talk actually because I had this concept of having DIY 4G networks as community learning infrastructure. So we actually have a community volunteer organization, and we all use this infrastructure to learn about how 4G and 5G works. So I often, teach some of this, although I'm much more familiar with 4G because we deploy it, in the field, whereas, we see 5G because we use the open 5GS stack that Mo was just talking about. Let me see. Okay, yeah. Going back to Steve's presentation a little bit, he used the term community networks, and this might not be familiar to everyone. So I just wanted to backtrack a little bit. Community networks are networks that are owned or operated by a community in a grassroots or participatory way. So you do DIY network building. And this is the first community network I ever worked on in 2012 as kind of a personal project while I was in school in my undergrad. So, and this was in Tanzania. It was at a very rural, remote school, totally off grid. And we were using 3G networks at the time to connect them to the internet. So my research field is in community networks, and we have built community networks. This is actually a 2G network in the Philippines in like a remote cove community. Again, for like very basic internet connectivity and just telephony services. So this was all done using open source as well. There are many different community networks around the world. I won't go through this in detail because this is a whole other, area. And this is, I guess, one of the most influential community networks that inspired our Seattle project. This is NYC Mesh in New York City. So NYC Mesh is a wonderful organization. They're also almost all volunteers, and they have a network that's mostly using what Steve referred to unlicensed wireless networks. So they are not doing, cellular like 4G or 5G. They're just doing using like devices that can just transmit without any spectrum coordination. So they're unlicensed, but they have a different network structure that like serves actually quite a large portion of New York. But they're also community installed and community run, just like ours. And so I would say we have kind of a community networks community of practice where we all share information, especially about open source technologies that we use. So these are some other networks that I've worked on installing, and these are actually open source 4G networks using that same software Mo was talking about. And for the Seattle Community Network, we have a 4G, it's sort of a patchy 4G network throughout the city where we use community centers. And we started deploying this in around 2021, where we'll partner with a community center to set up a cell site. And then at local low-income housing and homeless shelters, we'll actually put up receivers, like little modems that receive from the cell tower. So like this is across the street from the community center, that orange building where we have deployed the cell networks. And so this is a demonstration. This network is 4G, but the 5G network that you would build using the same software is almost exactly the same in terms of appearance and technology. So now we can actually support phones, and we have a capability to do eSIMs as well. So instead of putting the physical SIM card in your phone, you could use the eSIM. And at this point, we have these cell sites already. So we've got a Filipino community center, a few high schools, a few libraries, et cetera. And these are the places where our network kind of emanates from in terms of wireless coverage. And one of the basic goals of this network was during the pandemic, we started to roll this out as a pandemic relief initiative to provide internet access for people who are low income, who don't have internet access already. And so this is, for example, at a homeless shelter, which is, it's called a tiny house village. We have these little sheds which is kind of more informal housing, but it's because we don't have buildings to house people. So we have to build these tiny house villages. And so what we did was we had our LTE towers here, our 4G towers, and then we had these modems, these receivers receiving internet from there. And then we had Wi-Fi routers to broadcast that around the internet connectivity around the village. And now, these days, we've actually switched some of our what we call backhaul, the internet connection that a place uses to get its internet connection from, to like 5G wireless, just because we don't have complete coverage everywhere, and we've expanded our like shelter sites that we serve. So sometimes we've had to use 5G in order to get internet access to a place, and then we use Wi-Fi to distribute that access, because people usually have Wi-Fi devices like their laptops, tablets, phones, etc. So yeah, this is, examples of the types of networks we serve. Like you can see, these are the small sheds, and we'll deploy like Wi-Fi access points, basically. As this is actually like a lot of the points that Mo made, I also had in my talk, because basically you just do site surveys and you like will set up internet at a given place. It's like pretty much the same process, whatever kind of network you're deploying. And just to go back to the spectrum discussion, so these are slides that were in here like before I saw the other two talks. So I just wanted to like call out, this is very similar content, but this is basically a chart of the United States frequency allocations that shows how the US government manages frequency spectrum. So these represent like use cases for the spectrum and how it's sliced up. So like you would say, some amount like from this megahertz to this megahertz is used by this radio station versus that radio station versus, naval radar, etc. And this is already a few years old, so some things have changed, but we in our network, we use the CBRS spectrum that both Mo and Steve were talking about. So we're in this general access tier. You've got a tiered system of different priorities where the general public is able to access some spectrum, and then you've got priority access license holders, and they paid a lot of money to buy those at auction. But the nice thing about it is that in any given county, at most half of that spectrum can be priority licensed. So there will always be some left over for the people who are general access users like us. So this, it's not completely free to use this spectrum. So even for us, I had to get a special license, like taking a test and, paying some money to get a license. It was about $600 to say, I know how to install these networks and I'm qualified. So it's like any other kind of radio operator exam license. And then, so I get to sign off on these devices, and I have to register them actually in something called a spectrum access or spectrum allocation service. And these are run by a few wireless companies, including Google and Federated Wireless. But this is an example of, this is actually from 2021, a map of how much spectrum was available for like use by cellular networks and other licensed use cases. So it was quite open back then. And so now we see a lot more. This is like our, current deployment. And we see a lot more usage. So there's in this same area, less spectrum availability, but there's still quite a bit of availability. So over time, more operators have come in and used the CBRS spectrum, which is a good thing. So we should keep it. So I was talking about communities of practice earlier. We have all these tutorials on our website about how to use Open5GS and use actually, this is an old picture. So we used to maintain our own software package called COLTE, or Community LTE, for configuring Open5GS, but now we don't, because Open5GS has moved kind of past our ability to maintain this package. So now we just use straight up Open5GS, but we use this commodity hardware, Bicells hardware, like Mo was mentioning. And so this is now, Open5GS. I have a link here, but it's funny, I had this diagram too, the same diagram from the Open5GS quick start. And this may look intimidating at first if you don't understand what the components are, but you can kind of see. So you've got what you call the 4G or 5G core network. So this diagram is actually showing the full 5G like stack that they have. And then each of these pieces, as Mo was mentioning, is what you would call you could refer to it as a base station or as a cell, like basically this gear right here, the radio. And so this is the tower that you put on the building or on the tower itself. And then this green box is the software that's running on a little computer. In our case, you could do a little server, you can do a little computer. And then within that, so these software components, each of these boxes is a little software component. It's like a little program. And so the purple is what we are running on our networks to do just 4G. But overall, this whole box is the 5G architecture. So you can kind of see how similar the architectures are. The advancements are not, I would say that the real difference when you say 5G versus 4G, you get really higher performance with 5G. It's and so when the cellular companies are deciding, like these industry bodies are deciding when to release a new like generation of technology, I think it's mostly probably based on the user experience. Like the end user will notice a difference if they have a 5G phone versus a 4G phone, because of the speeds that they experience. But and that's partly due to the software, but really also due to the hardware advances and the fact that you're using these often smaller coverage areas with each radio, but more radios in like a denser configuration in urban environments. So it's really designed to serve like a more specific, very highly populated area with much faster speeds per user. And so like I would say, in terms of the technologist understanding, I don't think they're too different. And certainly so I buy a lot of hardware for running this network, and I explore, how much do these hardwares cost? So I ask for quotes pretty regularly, and so I just wanted to share the equipment we were using. Like this is a picture of one of these 5G base stations as opposed to the 4G equipment that I had here, and they look pretty similar, to be honest. They're so the 5G equipment, I would say it's more expensive, but it's not like outside of the range of possibility for even small groups. Like especially if you get a grant, you can deploy, if you only need like one base station, you can deploy a 5G base station, and it's not like hundreds of thousands of dollars. It's in the low tens or even less than $10,000. And so, yeah, I think we're getting to the point where small groups can deploy 5G, and it's almost as accessible as a few years ago in like the pandemic when I was deploying 4G networks, and the cost for the equipment was around maybe $4,000 for one of those base stations. So, yeah, and even now there are really interesting products out in the market. This is like a small cell, like a really small cell, it's like 2x2 MIMO, and 250 milliwatts per radio. So like very low, like pretty low power, but it's integrated with all these other technologies. So like is 4G, 5G, and LoRaWAN for IoT devices. And this is like, it's basically, it looks like a lamp. It's like the form factor of a lamp, and they show these marketing pictures of you putting it on your desk. So they're really designed kind of it's powered by Raspberry Pi. It's kind of for the hobby market. It's kind of for like, IoT people who want to test things out. But this is also, if you look into the documentation, it is based on Bicells hardware. So it seems like they took a Bicells radio and they stripped off the case and they put a new case on it, and they put in a Raspberry Pi and some other radios. But you configure it just like a Bicells equipment. So you could follow some of our tutorials, but they have their own tutorials as well. And this is also within, the same price range as I was talking about, like a few $1,000s. And so we use this, just to wrap up, like as a community-based platform for research in my research lab. So we had the community LTE open source package. We had a project called DAuth, or decentralized authentication, where we upgraded the functionality of Open 5GS to include like a decentralized way to authenticate users, so you don't have to do roaming. And then we have also this like disaster resilience project. And these are some of the deployments that we've done recently. And so I just want to emphasize, like, if you did a 5G deployment, it wouldn't look too different from this. And you could do it with community members, and in this case, like workforce development trainees. Yep. And okay, so that's my talk. Thank you.
Thank you so much, Esther, for those wonderful insights. Love listening to it. So before we dive in from questions from the audience, which we have quite a few, we wanted to open the floor if the panelists had any questions to each other before we dive in to a couple of questions we have from our audience already. So I leave the floor open to any one of you if you had questions with each other regarding the presentations or any more curiosities that are there.
So should we just start with the first question first?
Sure. If you guys don't have any questions from each other, I can start with the first question that we have from our audience. So our first question is actually from Irene. So her question to all of you is, how do you see regulators responding to the idea of decentralized 5G networks running on open source software and commodity hardware, especially when these networks are not commercially owned?
I'm happy to take a first stab at that. I think in general, well, I mean, the US is a bit of a special case in that the US has been a real pioneer in spectrum regulation, and in general has been a champion of kind of decentralized access, both in terms of unlicensed spectrum with Wi-Fi and also with licensing like this. The operators in general are the principal entities pushing back against this, because the way spectrum is assigned through these auctioned licenses has some side benefits for them, as in that it kind of firewalls the competition from them. So if you have access to these nationwide spectrum licenses, you essentially become part of a kind of an elite cabal of operators who can access the spectrum. And so it's hard to overstate what a huge paradigm shift the CBRS is in terms of access to spectrum. So historically, I mean, spectrum licenses have been granted on the basis of exclusivity. So if you get a spectrum license, you are granted exclusivity everywhere you have that license in the frequencies that you've been assigned. CBRS turns that paradigm on its head and says that instead of a right to exclusivity, what you get is a right to protection from interference. And that's huge, because it means that where you build a network, you have the right, you are protected. But where you aren't building networks, probably in underserved rural areas, you don't have that you don't have the rights to that spectrum, and the regulator can make a decision to assign that spectrum to other operators, and that's exactly what's happening in CBRS. The problem is that, there's a huge telco lobby that is kind of pushing back against this kind of licensing, as well as governments who see spectrum auctions as cash windfalls. And typically that hasn't happened in the US. It's mostly been in emerging markets where spectrum auctions are just like this. They were, a huge cash grab for the fiscus. But what we're seeing now in the pushback and the trying to reclaim CBRS spectrum and is actually a push to seeing spectrum licensing as a source of revenue for the government, which then becomes problematic. I'll stop there.
Thank you.
Thank you, Steve. So we have another question from the audience. It's not addressed to anybody in particular, so feel free to answer it. Question about community networks, and this comes from Sabahat Iqbal. Can you describe how you measure performance and how they stack up against traditional networks?
I guess I'll just from our experience running Seattle Community Network, it really depends on how the network is set up, and also, you know, what standard you're operating off of. So NYC Mesh, for example, they have an unlicensed wireless network, but surprisingly, they have somewhat higher performance than actually most other providers in the areas that they serve, especially considering the cost. So because they're all volunteer run and they're not like they're nonprofit, so they're not profit motivated, they do not like charge, they charge maybe like less than half. It's like $20 to $50 a month. So they charge less than half of what other operators provide, and their speeds are not limited based on the price you pay. So everyone gets, you know, about as fast network speeds as everyone else has, which is about maybe 300 megabits, which it or more, and that is pretty good. And in terms of like uptime, you know, you do have, I think there is a tendency for these DIY networks to have slightly lower uptime just because the people involved are, you know, they may be learning and onboarding a large amount of the time. And, you know, so, like there's a lot of infrastructure, especially in a mesh network. So, you know, nodes may go down and your latencies may fluctuate like throughout the day. So that is, I think, a core aspect of community networks, like based on the fact that you do not have staff on call to like address certain problems, and you're not being as conservative as possible about how you operate your network. So in our network, like we have probably less than a tenth of the number of volunteers of NYC Mesh. But we have a very relatively small network, but I would say our uptime is somewhat lower just because of the capacity of the volunteers. And so you kind of have to, like, at least for us, we have a totally free service because it's like currently only serving unhoused people in shelters or like low income people. So, you know, they kind of understand this is a free service run by volunteers. Like sometimes we have to sleep instead of servicing your problem. So it's okay. But if we were offering a paid service, then it would be slightly different. We might want to consider, like, we would have to consider having people on call and stuff like that. And yeah, so that is, you know, kind of the reality of it. We do, you know, the standard network monitoring, like we have a Libra NMS system that does SNMP, and we use Unify, and we like have monitoring systems just the same as other wireless ISPs. So we try to have as much uptime as possible.
If I could try to join that conversation. So yes, in terms of performance, I think one of the things that can be considered is that once you do deploy your network, there are definitely tools out there that'll help you measure KPIs that exist in the network. Some basic ones would be things like, you know, accessibility or data throughput or mobility. So these also can be monitored. Some specialized tools exist. And also some open source, but that's also from the field point of view to see what it feels like in the field.
Thank you so much, Esther and Mo, for answering that question. I have one more question, and that's from Irene again, and it's specifically for Esther. So her question is, could you share a bit about your experience navigating through the CBRS licensing process? Were there any unexpected challenges or moments that shifted your thinking?
I guess one interesting thing is that I would say our network joined kind of the CBRS user community really early. We were kind of like, you know, we were trying to get in the Spectrum access systems like before they were even online. So like in 2018 or so, we were like, where are these systems? We want to onboard to them. And so we encountered hurdles based on how early it was, which I don't think are, that much of a problem now. So the first thing I would say in the licensing process, like when you take the test to get your license, if you are already a radio operator, like for example, I'm a ham radio operator, like I think if you have experience operating radio, the test is not that hard. If you like study, there's like a video series, like what is that, a Coursera course even provided by Google, and like there's other training courses that you have to take as a process of, like, usually they bundle it in with taking the exam itself. You just like watch this video series, and it's all concepts that are very familiar to radio, like radio propagation, and why you have to provide all the details about your radio installation, including the height, the geographic coordinates, and where your antenna is pointing, and how much gain the antenna has, because what the system is doing, the spectrum allocation service, like the software system, is modeling the propagation of the signal so that other people who have licenses near you don't interfere with you. So you have to put in all the radio parameters correctly, but if you understand radios, you already know kind of how to do that. So there have been, it was really like when I was first learning this, there weren't many other resources like to help with confusions and exactly what values to put in the spectrum access software, but we were able to figure it out because me and my lab mates were already doing radio, and then now I would say it's a little bit easier to onboard, and also back in the day we were like, for example, in order to even set up an account on the Google spectrum access system, there was a barrier of like $5,000, like $5,000 you have to pay as a deposit even to get into the system. And I don't think they have that now, but it is, they assume that you are a telecom company essentially. So they have these like price barriers sometimes. Yeah, and that's there are other challenges, like for example, if you try to update your configuration on these devices at like 11:30 p.m. to 1:30 a.m., like the databases don't sync because they don't expect anyone to be working at that time. So they're probably using that as maintenance of their system or like just syncing all the databases, and they won't take any additional configuration changes as input. So things like that are also challenges, but they maybe only apply to graduate students. And yeah, so those are some examples.
Thank you so much. And as a tiny follow-up question, for anyone who wishes to dig deeper in that, would you be willing to share any resources?
For sure. I mean, I teach this stuff like to our other volunteers and to other community members. So I have like a Google Drive folder of teaching videos that I can share. I also have all these slides, and of course our Seattle Community Network documentation site, which is a little out of date. We're trying to update it, but that all of those I guess I can share to the organizers, and maybe they can send it out.
Yeah. Thank you, Esther. There's just one last question, and this is for, any one of you to answer. Are there any international policy frameworks, regulations that could hinder or help countries create locally governed spectrum access for 5G?
Every country has sovereignty over their own spectrum, but or almost all countries are signatories to the International Telecommunication Union, which is a treaty-based organization through which there's coordination on what spectrum is used for what. In theory, there's no obstacle to it, but there is a distinct lack of civil society voices within regulation, both nationally and internationally, asking for this kind of licensing, because those fora are dominated largely by large corporations who can afford to send people to it. So, if I could leave with one message, it's that there's a crying need for civil society organizations to have their voices heard at regulatory agencies asking for access to this kind of spectrum for community-based networks, for cooperatives, for municipalities, and local ISPs in general.
Mhm. Yeah, and thank you very much. I think it is different in every country, but just like we've seen with Wi-Fi, there's the 2.4 and the 5 gigahertz that are also available to be used, but there's a lot of interference there. And then there's another challenge is that there is no SAS verification outside the US, as far as I know. Places like Japan and South Korea have come up with their own spectrum for this kind of deployment. Yeah, hope that helps.
Yeah, thank you very much. Can't believe we've almost, we're at the end of this wonderful discussion. And I just wanted to thank everyone. It was an incredibly enlightening discussion. And of course, a big thank you to our wonderful panelists for sharing their expertise. Due to time constraints, we weren't able to explore every aspect of the topic. However, the depth and quality of today's discussion was remarkable. Thank you again to our panelists and to everybody who joined us today. Remember, you can stay connected with Zero Day Dispatch through our website, newsletter, our LinkedIn page, Slack, and other social media platforms. I've added them all to the message below on Zoom, and all of which I've also, as I just said, added to our chat. We look forward to continuing these crucial conversations. Until next time, thank you so much.
Thank you.
Thank you so much, everyone.
Cheers, everyone.
Thank you.
Bye-bye.
Thank you.